Okay, pre-calc. Here, let's go here. Let's see how we do here. Let's talk about sets, baby. 0, 1. So not technically chapter 1, but chapter, a little precursor to chapter 1. So we're going to talk about set notation and denoting elements and subsets, and then intersections and unions and things like that. Okay, so let's get rolling. First, what is a set? A set is a collection of objects, and we name those with a capital letter. Okay. As with all these videos, just want you to know you can always pause and rewind and go back and get something if you didn't understand. You can rewatch it a number of times. It'll always be here for you. Okay. So I encourage you to do that. Pause it if you need to write stuff down. Rewind, take it slower, do what you need to do. Okay. So we name those sets with a capital letter. Back to it. An element. An element is an object in a set. Okay. So we use these braces or these brackets to kind of label it. So the elements are contained within the braces. So the symbol here, this like E-type symbol with like a curve, says that means is an element of. So that's how that reads when you see that symbol. So it is an element of. Okay, so let's look at some examples of some sets here. All right, so here's some good examples that we can look at. First, we have the set name. The set is named C here. It's the pages in a chapter of our book. So maybe this chapter contains pages 35 through 40 here. So the set notation, you see the brackets would be on each side of 35 through 40. A is the students who made an A on the test. Okay, so we would look at that and say, all right, well, we've got these students, Belinda, Mario, and Karen, they were all in that set there. Okay. L, the letters from A to H. The letters from A to H. So those would be in here, A, B, C, D, E, and F. You can see those right there. And then same thing with the last one, positive odd numbers would be in this set. 1, 3, 5, 7, 9, 11, 13, and then and so on with the dot, dot, dot. They would all be in the bracket as positive odd numbers. So those are some examples of some sets and how we would write those as such. Okay. All right. Continuing on here, let's do some practice then. Okay. So we practice here. Practice says use set notation to write the elements of each set. Okay, then determine whether that statement is actually true or false. So for number 1 here, we take a look at it. For 1 says, n is the set of natural numbers less than 3. Okay, again, so n would be the name of the set, and it would be set of natural numbers less than 3. So we look at that. If we were to write the set, what are the numbers, the natural numbers less than 3? So n equals, and then we're going to use that bracket notation, okay, or the braces here. Say, what are the natural numbers? So we're not talking about integers. We're just talking about natural numbers. Those are your counting numbers. So we don't even include 0 here. So it would just be 1, 2. And that would be it, right? Less than 3, okay? And then we put the n bracket on here, and away we'd go. So now the next statement says, is this statement true? Is pi an element of? Remember that symbol means an element of. Is pi an element of set n? Well, that would be false because pi is actually going to be what, 3.14? So pi being 3.14 tells me that it's not in this set. So that would be a false statement here. False. Okay. So moving on. That seems easy enough, right? As we continue on here, let's look at the second one, number 2. C is the set of consonants before H in the alphabet. Okay. So if we again label our set C here, and so now we're looking at consonants before H. Well, A is not a consonant, so it wouldn't be in there. So we're looking at B, C, D. E is a vowel, so we won't list that one. F and G, and that would be it, right? The next one would be H. So those are your consonants that are before H in the alphabet. And then our statement here says D is an element of C. So is that true? Yes, D is right here in the set. So that would actually be a true statement here. Okay, that seems easy enough as we go. Okay, moving on. Oops, there's a purple line. I don't know how that happened. All right, so as we continue. All right. Let's get, oh, I see. Okay, now, so this next part says if every element of B is contained in set A, then B is called a subset of A. And then we write it like this. It's written B, and it's kind of got that sideways looking C or sideways U. B is a subset of A. And the universal set U is a set of all possible elements for a situation. All other sets in this situation are subsets of the universal set. So that's better described with this diagram here. You can kind of see that U, in this case, this whole thing is the universal set. It exists. It has A and B inside of it. Okay. And you look at B, that is the set B is completely inside of set A, right? All of B is inside of set A. So B would be a subset of A in this situation. Okay. So let's kind of look at that now using that idea with, do I have an eraser? Yes, I do. Good. Okay. So let's look at this with the idea of, not that. So scroll up here, not that either. Here we go. Okay, so this idea here, suppose that A is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, and B is equal to 1, 2, and 3. Okay, so with that, because 1 is in set A, right? 1 is here. It is also here. Oh, I don't even know. Yep. Because 1 is here and also here, and 2 is here, it's also in the set here, and same with 3, because they're all in that set, then we could say that because 1 exists as an element of A, 2 is an element of A, and 3 is an element of A, that's the entire set here, then we could say that B is a subset of A. Okay, so one last thing on those subsets is that everything else we would say is the complement. Okay, so in this case, we would say that B prime is the complement of B. And these are which all of the elements of the universal set U that are not elements of B, right? So we think about that in that last example there, we would say that, 4, 5, and 6, 7, and 8, those would all be examples where they would not be elements of B, so they would be complements of B. They're also in U, though. All right, so let's move on to unions and intersections. Okay, a union and an intersection here. A union of sets A and B is written A union B. Okay, this written here. Sets A and B. It's a union. It's consisting of all that are in A or B. So that's the key fact here. It's in either A or B. That would be called a union. Or an intersection, and notice the symbol. Intersection, we flip the symbol over and say this. An intersection is where we have A and B as elements consisting of A and B in this case. And then the last thing we have written here in unions and intersections is if two sets have no elements in common, their intersections are called an empty set, and you can write it two ways. You can write it with the 0 with the slash through it, or you can put those little braces and put nothing in there. Either one of them works. Okay? Either one of them would be okay. So let's look at some problems involving unions and intersections then. Okay, so if we look at a union here, we've got our universal set U that contains all these numbers 1 through 8. And then we have R has 2, 4, and 6 in it. S has 4, 5, 6, 7, and T has 1. So the question they want here is find R union S. So R union S is, again, remember, a union is the set consisting of all elements that are in R or S. So we're thinking here, it's going to be R or S. So R or S. Okay, so in that case, what are those numbers? Well, that's basically looking at all these, right? 2, 4, 5, 6, 7. They're in either R or S. So that would be our set, basically. We would say, here's my bracket, 2, 4, 5, 6, and 7 would all exist, would all be an element of either R or S. Right? Again, key phrase here being or. All right, let's go down a little further now. Let's check about R intersection S. So remember, intersection is, it has to be in both R and S. So there's only two numbers here that exist in both R and S, and they're sitting right here, 4 and 6. Okay, so for R and S, that would be our, and we're thinking and, it has to be both in R and S. There's only two that do that. That would be 4 and 6. Would be the only ones that accomplish that. All right. So continuing on to the last problem here. We're looking at this and say, find T intersection S. Well, if you look at this diagram here, T is kind of all by itself over here. Nothing is there. So T is not going to be and with anything. Remember, this sign means and. Okay, so there is nothing that T is that's going to be in T and something else. So simply, this is where we could come up with our no solution and write it, and write it like this, through the line through it, or we could also write it this way, with nothing in it, would be the empty set. Okay, all right, so that's our first video of the year with 0-1 sets. So watch this, take those notes, and then be ready to go on an assignment tomorrow in class. All right. Get rid of that. I hope you enjoyed this video.